It's a little demo of the civil drawing that we're going to be doing for applications of AutoCAD. This is from the handout. We've got the structure or the outline of the building on a plot plan, and the drawing has to be done using surveyor's units, and the surveyor's units are in that format right there. The south 85 degrees, 44 minutes, 51 seconds west just means that that line starting from A would be going due south and then swung toward the west by that amount. If you look at the surveyor's units for the bearing over here, you start a line going due north, it swings toward the east by 11 degrees, 1 minute and 30 seconds. To do this drawing, I'm going to show you how to create a user coordinate system, rotate the coordinate system so that the x-axis falls right along that bottom property line, use the plan command so that the orientation of the plot on the screen is nice and straight, making it a lot easier to put the footprint of the property in the driveways. And then go over to a layout and set up the layout so you have a view of the entire plot plan. And then you have a separate detail of the house itself, where the house has a different orientation. I'm also going to have you use a different scale for the house. And because this drawing is being done in feet, the units are going to be feet, decimal feet. When you go to plot it on a sheet of paper measured in inches, there's going to be some interesting things you have to worry about, or at least have to understand about scaling when you have different units for the sheet of paper than the object that you're drawing, or from the thing that you're drawing. So I'll switch over to AutoCAD. I'm going to make a new drawing. I'm going to start with imperial units. I'm going to go into the units command, and under decimal I'm going to leave it set to decimal because we're drawing in decimal feet. The precision we can leave here to 4 decimal places. When we dimension it, we'll set the precision for 2 decimal places. Change the insertion units from inches to feet, which means that if we were to bring in a drawing of a house, for instance, that was done in architectural units, that drawing would have been done in inches. If you insert a house into this drawing, where the units for insertion are indicated as feet, the house will be scaled to 1/12 of its actual size so that it fits onto the lot correctly. Now the angle type we're going to change from decimal degrees to surveyor's units. The precision has to include both minutes and seconds, so we're going to go down to the third option. So we have degrees, minutes, and seconds. And notice the letter D indicating degrees. It's going to be useful when we actually place these. Pick OK. Don't change anything else. Don't change this to clockwise because surveyor's units assume clockwise direction. Now I'm going to change my limit to 500 by 500, and that's 500, 500 feet. And I'm just doing that so when I do a zoom all, we have enough real estate here to actually draw. Before I start, let's do something else that's a little bit different. I'm going to go and set up a layer. And the layer I'm going to set up is going to have the name C for civil dash PROP. So that's just going to be our property line for the civil drawing. I'll make the line weight 0.5, so it's a thick line. I'm going to do something else a little bit unusual. My line type I'm going to pull from a different file than the standard AutoCAD file. I'm going to go and load a line type. And I'm going to go not to the one that comes up, ACAD LIN, but I'm going to go and browse and go to the R drive. In the R drive, on AED 160, there is a line type file called acad.lin as well. And if you open that up, it contains a custom property line type. This is one that I created for Liv Jamison because she likes having the letter P and the letter L kind of on top of each other and offset a little in a property line. So I created a custom property line just to show you that you can go and pull a line type out of another file. Pick OK. Now that line type is going to be fine even if you send this drawing to someone else because, let me pull my over in the screen, because line types are stored once they're loaded in the drawing itself. So there's my property layer. I'll be setting that current. Got a property line type, which is a custom line type. You won't find that anywhere else. And then we'll go ahead and do the drawing. I'm going to draw with a P line. I'll just pick any old starting point at all, say right about here. I'll go back and take a look, and you notice what I'm doing is starting from A, and I'm going to go at 294.93 feet. And even though there's a foot mark right here, since the units I'm using to draw in AutoCAD are feet, I don't include that foot mark or else AutoCAD won't know what I'm talking about. So if you have the handout in front of you, it'll be a little easier to follow this because I won't be going back and forth. Let me go back to AutoCAD now and we'll start doing the drawing. This is the second video in of the civil drawing for the Applications of AutoCAD class. Everything is set up. We've got a line type, special loaded line type called property. I'm going to go to the P-line command. I'll just start a point right about here. That's going to be point A from the handout. Again, just one more time, that's what we're drawing is a civil plot plan. If you have it in front of you, it'll make a little more sense as I go through this. Now I'm going to have to use polar coordinates to type these values in. So I start with the @ symbol. I'm going to type 294.93, no foot mark because we're drawing in decimal units, at an angle of south 85 degrees. Since there's no degree symbol on the keyboard, you have to use the letter D to represent it. 44 minutes, 51 seconds west. When I press enter, it draws a line like that. Match that up to the line you're trying to draw. If it looks about right, it probably is. At 166.82 at an angle of north 11 degrees 1 minute 30 seconds east. At 122.54 feet at an angle of south 83 degrees 12 minutes 25 seconds east. At 146.72 at an angle of north 53 degrees 50 minutes 52 seconds also east. And then when you get done, do not go back to the endpoint and snap to it, because that's not how a survey would be checked. We're going to actually type in all these values, and when you're done, there'll be a small gap there. That gap will be really an indication of the accuracy of the survey. So at 214.98 at an angle of south 5 degrees 53 seconds 53 minutes 20 seconds east. It looks like it closed right up, but if I zoom right in, you'll notice there's a little bit of a gap there. You can also see this line type that we're using with the P and the L for property line, and you probably recognize that it's way too small. When we go over and set up a layout, it'll actually be a lot larger because PSLT scale, the variable that controls the display of line types in paper space, is currently set to 1. If we wanted to, we could set a scale over here and set MSLT scale, model space LT scale, to 1, and then that line type would show up with the letters a little larger. But I'm just going to leave it for right now just the way it is. Okay, this is video 3 of the civil drawing. In this case, we're going to go ahead and draw the building. And the building plan, or the footprint of the building, which looks like this, is parallel to that bottom property line. So we're going to draw it, but it'd be an awful lot easier to draw if we could use direct distance entry. We can't do that currently because that property line doesn't match up with our coordinate system, where the x-axis is horizontal. So what we're going to do is change the coordinate system using a command called UCS. So I type UCS, enter, and I have a lot of options, and there are actually some options that are kind of hidden that might not be as obvious. First thing I'm going to do is to type O for origin, and I'm going to select that endpoint right there as my origin. Now you notice that the user coordinate system icon moves over to the origin, and you can see that little angle right there. What I now want to do is to turn or rotate the coordinate system so that the x-axis lines up with the bottom line in our property. That means I'm going to pivot it around the z-axis, which is right there coming straight out of the screen. I go back to the UCS command, and I'm going to type Z. When I type Z, it asks me for the rotation angle around the z-axis. I could do a little calculating and figure out what the angle is between horizontal and that line, but I don't have to, because if I select the endpoint of this line and the other endpoint of this line, once I've done that, it'll rotate my coordinate system so that it matches right up with that line type, with that bottom line. Do that one more time. UCS, Z, it asks for the rotation angle, select the point here, and I can actually select a point anywhere along that line, and I can even use the extension object snap that pops up, and it's extending the line that I'm on. Left click, it rotates my coordinate system into place. Now what this means is if I wanted to start drawing, I'm going to be tracking on my new coordinate system so that I could actually lay the house in there fairly quickly by just saying, let's start this at 115,70. Then I can start dragging, say, straight up, indicate I want to go up there 40 feet, and I can come over here. Now, if you don't like drawing at an angle, you don't like the sort of way that looks, it feels a little crooked to you, what we can do, just erase that, we'll go back and do it again. What we can do is tell AutoCAD to display on the screen the coordinate system so that it is actually in plan view. And the command for that is plan. If I press enter, the default current coordinate system is the default. Press enter one more time. Now my coordinate system has been rotated, but my view of the screen is rotated back so it looks nice and square. Now I've got a situation where I can draw the house as though I'm looking straight at it, where I go straight up, type in the 40, go to the right, type in the 20, go straight down, type in the 5, go over here, type in the 20, go straight up, the 5, come back over here, 30, and again we're drawing in feet now. This is not an architectural drawing, this is a footprint of a piece of property, and since it's being drawn in a civil drawing, everything here is being drawn in feet. Come down to here, like so. Go this way 10 feet, go straight up 10 feet, go straight over 30 feet, go down to 10, and then go over here. These numbers are obviously chosen just to make it fairly easy to draw. And I brought the help system up, not because I wanted to, but because when I went to hit escape, I hit the F1 key instead. Now I've hit escape. Now I notice that I put this house on the same layer as my property lines. I don't really want that, so let's go back up to the layer command. Go to 0, make a new layer. This layer is going to be C for civil-BLDG, so because I'm going to put in the buildings on there. I'll leave the line type set to continuous, set my line weight to 0.5. I'm just going to close that to get out of here. Now I'll grab this, put the building on the building layer. I'm also going to close the quick properties window. And just to keep track, why don't we go ahead and make the building layer blue instead of black so it shows up a little better. Make it current, come back out, and now we'll finish up the rest of it. But we may as well go ahead, let's do a couple more layers. We'll do a couple more civil layers. One of them will be C-DRIV for the driveway. We'll do another one, C-DRIV-PATT for the hatch pattern that's going to go on the driveway. And then we'll just leave that at that. I'll go back, make the driveway my current layer, come back out, and we'll put the driveway in. And through the magic of video recording, bang, the driveway and the patio are done. Now I'm done with the basic layout. I'm not going to put that hatch pattern in until I go and put a layout on the, when I said layout, done with the layout on the piece of property. When we go over to one of the layouts in the sheet, then we'll go ahead and put the hatch pattern in. But right now I want to go back to where we were before. So I'm going to type UCS and then press enter because the default value is world. The world user coordinate system is the one you started with, the one developed by René Descartes. You see that my view is kind of skewed, and that's because I turned the view on the computer using the plan command to match up with the coordinate system I created. So I go back into the plan command, and now the current user coordinate system is the world. I press enter, and now I go back to the property and the orientation. It actually is in Earth. Now let's go to a layout. We go over to the layout. And when we get to the layout, it just has the default size. So what I'm going to do is set up a C-size sheet of paper, go ahead and set up my views, but I'm going to do that in the next video. So let's just stop this one now. This is the fourth video of the civil drawing. We've gone over to a layout. Now we're going to go ahead and set that up with multiple views. I'll have you in the class set this up on C-size paper, so you'll be using somewhat different scales. I'm going to start, I think, by using, well, I'll go with B-size paper. It means you're going to have a different setup so that whatever I use for scales here is not going to work for what you're doing. And obviously the point here is so that you can set it up yourself and make sure you understand it and not just kind of duplicate what I've done here. So So go over to Modify. We'll go ahead and pick a sheet of B-size paper. It's just kind of unrealistic for a civil drawing, but that's alright. See, B-size paper is 11 by 17. I use the monochrome plot style, or the pen style, and everything else I'm going to leave just the same. We'll close this up. Now I'll just go ahead and move that primary view and sort of put it over here like so. Get something set up about like that. Now there's an important distinction here you have to make, and that distinction is between a viewport scale and a plot scale. So let's make a few notes over here just temporarily. Viewport scale is an AutoCAD scale. A plot scale is the real world scale. If the units that you use to create your object or your drawing are the same as the units you use for plotting, in other words, if you draw something in inches and plot it in inches, same units, scales are the same. However, in this case, we have different units for what we've drawn than how we're going to plot it. Let's just take a look at what a scale really is. If you have a scale in AutoCAD, your viewport scale is going to be paper space units to model space units. So a scale is always paper space to model space, the units on the sheet of paper in relation to the units in the real world. So what we have in this case is our paper space units are going to be in inches. So if we have a scale, a viewport scale like 1 to 100, what that means is 1 inch to 100 model space units. Model space units are not inches, they're feet. So that's the viewport scale. That means the real world scale would not be 1 to 100, it would be 1 to 100 feet, or 1 to 1200. That's the difference in the viewport scale and the plot scale. But it's always paper space units to model space units. So if your units are different, you just have to recognize that to determine your actual plot scale. So when we're done and we put a plot scale in the title block, the plot scale we're going to put in the title block, because this is a civil drawing, would look like this. If we used a 1 to 100 scale for our viewport scale, which would in fact be a 1 to 1200 plot scale, it would be written in the title block as 1 inch equals 100 feet, because that's the syntax we use in the United States to represent scale on civil drawings. The 1 inch is on the left, and the number of feet it equals is on the right. The 1 inch never changes. So if we had a scale that was 1 inch equals 1,000 feet, it would be put just the same way. 1 inch equals 1,000 feet. Now I'm going to delete all these notes and go on from here. Okay, let's look at a potential problem here now. What I'm going to do is insert a title block, and the title block I'm going to insert is going to be for B size. A title block, when you create it, should be drawn full size, and for a title block, full size means the size that it needs to be to fit on a sheet of paper. So since this is a B-size sheet of paper, I'm going to bring in a title block that was drawn to fit on an 11 by 17 sheet of paper, so it'll come in at 10 by 16. So I go to the Insert command, I go over and browse in the General folder, and I'll use the TB inch architectural title block. I'll bring it in, and it comes in, asks me for some attributes because Meredith put some attributes in there, but I'm just going to cancel, and now I'm going to go, what on earth happened to my title block? You take a look at that. That title block came in much too small. If I were to select it, right click, actually let's just do a list. Select it in list. Comes up here, and I notice that it's got an X scale factor of 1, a Y scale factor of 1, and a Z scale factor of 1, which is what a block should be if I bring it in. But it's got something called a unit conversion scale of 0.0833, which happens to be 1 divided by 12. And the reason I'd have that is because back when we set up units, I said to AutoCAD, the insertion units for this drawing are feet because this drawing is being done in feet. So when you bring in something as an insert that was drawn in inches, scale it down so that it actually fits in here. That would have been great if we'd had a house that we'd drawn in architectural units. In this case, however, we have a title block we drew in inches, but we actually want it to come in full size in inches because we're in paper space now where we're dealing with inches, not feet. You can't set two different units, one for paper space and one for model space, but you can change your units at any time. I'm going to go back and reinsert. That block actually is part of this drawing now. And now it comes in the right size because I changed the units to inches. Now if I wanted to, I'd go back and change it to feet again. So if I do want to bring in any content that was drawn in inches into model space, it would come in the right size. Now let's try to determine a possible scale here. I'm going to select the edge of that. I'm going to go down to my scale list. I'm going to look and say, well, the viewport scale I'm looking for will be something in the order of, well, let's try 1 to 100. 1 to 100 is just a little bit small. Let's go back up here and say 1 to 50. 1 to 50 actually looks pretty good, so we'll do that and we'll lock it. Now, if that scale, that viewport scale, is 1 to 50, it means that 1 inch, in this case, is equal to 50 feet because the units in paper space were inches, the sheet of paper. The units we used in model space were feet for a civil drawing. So 1 to 50 as a viewport scale means 1 paper space unit equals 50 model space units, i.e. 1 inch equals 50 feet. So what are we going to put for a scale? In the title block, the scale is going to be 1 to 50. Now I'm going to go over here and I'm going to put a view of the house. I'll put another viewport right here. A little bit too much. What I want to do here now is put just the house in here, but I want the house oriented so that it's horizontal and vertical. So I'm going to go back to my UCS. Once again, let me zoom out just a little bit. I'm going to type the letter Z. I'm going to pick that point right here, another point along that axis. Get a plan view of that coordinate system. Now zoom in on the house so it looks more or less like that. Then I'm going to go over and fiddle around with some scales. I'll try 1 to 30. 1 to 30 doesn't look that good. 1 to 20 doesn't look too bad. What about 1 to 10? Yeah, it's not going to work. 1 to 16, which would be a little bit of an unusual scale in civil, but I'll try 1 to 16 anyway. Now if it's 1 to 16 as a viewport scale, 1 to 16 as a viewport scale means 1 paper space unit equals 16 model space units. So the actual scale here, when we put our detail in, let's just put house detail as our title. Go back under here at 1/8 of an inch and put scale 1 inch equals 16 feet. Again, why? Because 1 unit in paper space equals 16 units in model space, and the model space units are feet, and the paper space units are inches. This is the fifth video in the civil drawing. Now let's talk about putting the dimensions on here. In your textbook, there is a system for placing dimensions. And by the way, if you really don't like that the line type scale here, you can change that line type scale by selecting it, right-clicking, going to Properties, saying let's make the line type scale a little bit smaller. That way the letters will show up a little bit more often. So if you want it to look like that, I just set that to 0.5. You might want to do that. You might want to leave it the way it is. But what I want to do now is put dimensions on here, and the civil dimensions are going to be put on there so that the distance is above and the bearing is below. By the way, when you do this in AutoCAD, you're going to have the numbers over here flipped. Don't worry about it. This would be more appropriate, but it's a little tricky actually to get AutoCAD to flip those for you. So we're going to have the distance above and the bearing below. And to do that, I'm going to create a dimension style based on the one that's in your textbook. And that's the civil style is in your textbook. So let's go ahead and set that up. I'll start with the standard scale. Right-click, rename, call it civil. I'm going to go over here and modify it. And under lines, I'm going to suppress dimension line 1, dimension line 2, extension line 1, and extension line 2 so that they don't have any extension lines, any dimension lines. Under symbols and arrows, I'm not doing anything. Under text, we'll go ahead and set up text something reasonable about the Yeah, that's the Romanesque font. Height is 0. Don't forget, leave it at that. Width factor in this case is 8 with an obliquing angle of 0. Set that as my current layer. Close this. Come back over here. I didn't really need to set it as my current layer, just in case you're confused by that. I'm going to set the text height to 0.12, and I'm going to come down here and make my text aligned with the dimension line, but above it. Now I'll go to primary units, and I'll change the number of decimal places to 2. Since we're drawing in decimal feet, 2 decimal places is standard. And I'm going to add a little suffix to every dimension, which is the foot mark. We can't put angular dimensions in surveyor's units. It's not even listed, so we're going to have to do something a little creative for that. But right now we've got a civil plan, a civil style. Come out here, and the other thing I want to do under fit is I want to make that an annotative style. I'm going to make it annotative. Now I'm going to go ahead and place it. Before I do, I'll create a layer. So I have a layer for my dimensions. Now, our annotative scale, our viewport scale, is 1 to 50, which is going to make it our annotative scale as well. Since we've got dimensions that are annotative, make sure that's current, I'm just going to go and place a dimension. Now the kind of dimension I'm going to be using, because I want the dimension to line right up on that line, I want it to look just like that at the same angle, it's going to be an aligned dimension, not a linear dimension. DAL is the alias. You could also pick it off a toolbar. I'm not going to pick 2 points. I'm just going to press enter. I'm going to select the line itself. I'm going to pick a point on the line, and you notice it just puts the dimension directly above it. Go over here and do the same thing. Do the same thing. And I think you'd agree that that's a very fast way to do this. Here's the one place where just leave it the way it looks right there, and that'll be fine. That gives us our bearings. I'm sorry, not our bearings, but our distances. And very quickly, now I'm going to copy each one of these down below, the one that's there, and now I'm going to edit that and change it to the angle of that line. But because the angle of that line involves typing and the possibility of making an error, what I want to do is to automate it a little bit. We can't really fully automate it. I can't come up with a technique that'll automatically put that in there without writing some Lisp code. So let's just do it this way. Let's go and do a DI for distance on that line, starting at its start point. Go to its end point. When it tells you what the angle is, it'll give it to you as south 85, the letter D, because it doesn't have a degree symbol, 44 inches 44 minutes 51 seconds west. I'm just going to copy that from the command prompt, right click, copy it. Now I'm going to use the edit command to change what's there, replace what's there with what I just copied, get rid of those spaces, put a %% in front of the D, since that's the code for the degree symbol. Come out here, and now I've got my direction. I go ahead and do the same thing for each one of these. I say DI, what's the distance from here to here? I go up and just highlight it, copy it, go to edit. Before I do that, I actually have to copy this down below. Now I can go ahead and edit that. Paste in what I just copied, get rid of the spaces, again, % in front of the D, get rid of that space, come back out, and then now there's a different dimensioning system that we're going to use over here, and this is a different scale. Because it's an annotative dimension style, the annotative dimension style will come in scaled properly in either viewport based on the scale we set here. But that means it has to be a viewport scale that's from this list. It can't be a random scale. You can't just kind of zoom in and out with your mouse. So it's got to be from that list. So that's 1 to 16. I'm going to go ahead and lock that. The kind of dimensioning we're going to put over here is called ordinate dimensioning, and the reason we're going to do that is so that you understand how. And we'll bring that down a little bit more so we have a little bit more room, like so. Okay, so now we're going to lock that. Now I'm just going to go over here and put in one ordinate dimension using DOR and say, what if we put an ordinate dimension right there? Well, if we do that, we get 141.83 feet, because an ordinate dimension is from a 0 point, and without specifying otherwise, it used the current origin as a 0 point. So that's not a very useful dimension to us. We need to reestablish that as 0. The easiest way to do an ordinate dimension is actually with the QDIM command. QDIM stands for Quick Dim. what I'm going to do is to pick my geometry here, press enter. Now I want to have an ordinate dimension placed there, a series of ordinate dimensions placed, but I want to change what's called the datum point. I want to change the 0 point. Type P, select what you want as your 0, in this case right there. Type O so that I get ordinate dimensions. Now I'm just going to come over here, left click, and you notice that those dimensions all come in. The problem is they come in different precision than what I wanted, and also there's no extension lines. Well, that's because the dimension style I set up for Civil over here doesn't use dimension lines. So let's go back into our dimensions now, and under Civil let's add a new dimension style. Not for all dimensions, but just for ordinate dimensions. Now we're going to continue. So when we do ordinate dimensions, what do we want for lines? Well, we don't want to suppress the extension lines. We want them. So we're going to clear that. The other thing is, under text, we don't want the text to go above. We want it to be centered. Under primary units, we don't want 2 decimal places. We just want 1 in this particular case. So those are my ordinate dimensions. So I close that up. I come back out, and now you'll notice that I not only have my ordinate dimensions in here properly, but they also have extension lines coming across as well. Now that goes vertically. I go back to QDIM. This time I'll pick the geometry that I want to dimension again, this and this. This time I'll come up here. Now I've got the dimensions going across horizontally, and you'll notice that all the text is the same height in both cases. And that height, this is on B-size paper, that height, just put some text right beside this, that height is 0.12, the height that I used in my dimension style. This is video 6 in the civil drawing, and we have a couple things left to do. We have a few dimensions to put over here, and then we're going to have a hatch pattern, do a little bit with annotative objects, and then we'll be finished up. Our viewports are on a viewport scale. I don't remember if I did that in the last video or not, but that's so that they are non-plot. So right now we have a drawing that looks like this. We have a few dimensions to put in for the footprint to show where they go. We can't use the same dimension style for this, even though we did use the same dimension style for both ordinate dimensions on the footprint as well as for the property plan, because they're two different kinds of dimensions. But we're going to put some linear dimensions here, and because they're linear dimensions, they're going to be placed the same way. They're going to have to look the same as the dimensions we have here. So I'm going to go back in, and I've created an architectural style right now, and if I look at it, it's basically a standard architectural style. The text above, a few other things, the offset from the dimension line 0.04, just the way you would do it normally in architectural scale, and I'll make that my current scale. So now let me go ahead and put a few dimensions in here. Go down into model space for this purpose, DLI for the dimension, pick this point right here, I'm going to pick this point right here, and I want to put that 115 foot dimension. Why is it 115 feet? Because a linear dimension has two default settings, one horizontal, one vertical, but it's actually a rotated dimension. We can rotate it at any angle. So if we type the letter R, see, you've lost it on the command line, so let me go back so you can see DLI, that point right there, this point right here. If we type the letter R for rotated, we can rotate that dimension to any angle we want. All you have to do is pick a couple points on the screen at the angle you want the dimension to go. Now it rotates the dimension in place for you. We got the 115. Go back and do the 70. We're going to have a different problem. We still need to rotate it, so R for rotate. Do that. When we place this, though, you'll notice that the 70 shows up on the wrong side. I told you when we did the plot plan to go ahead and leave it. You could leave it in this case as well, but there are people who aren't going to like that because they're looking for this to be readable from the other side. So what we can do is this. I'm going to delete that. I'm going to go back in and add it again. So it's a linear dimension from here to here, and I am going to rotate it. The angle I'm going to rotate is from here to here, but I've got another option up here, which is angle. That doesn't refer to the angle of the dimension. That refers to the angle of the text in the dimension. So when I type that, it asks me for dimension angle. I'm going to pick the same points, or points at the same angle, because now when I place this, it's rotated the dimension to that angle. The only problem is that I have to drag the dimension itself up above to get it above the line, and it's not going to do that by default. If I go back in my dimension style, under text, under Fit, I'm sorry, under the Fit tab, text placement when text is not in the default position, beside the dimension line, over the dimension line with a leader, over the dimension line without a leader. If I select that as part of my style, now I can grab this and just move the text out of place by itself. So now I've got the 70 up above the line and it's rotated into place. Now if I go and do, say, the 16 over here, I'm going to have the same problem with that as I bring it across. First, let's rotate it from here to here. And I could, if I wanted to, go ahead and type angle, do the same thing. But once I've got one of these, I can just go ahead and place all of these things in there. Then I can use the match prop, MA is the alias, match properties command. So let's match the properties of this to this. It won't match the properties as far as having dragged it out of place, but it will match the angle. But since I've changed my dimension style, I can drag that up here like so. And by the way, if you've placed it and then after the fact want to make that change, in other words, suppose I placed this dimension, I'm just going to pick a couple points. Suppose I did a dimension like that, and it comes out on the wrong side. I can go to my dimension toolbar, pick the text edit button, and say let's edit that text, A for angle. Now I can pick the angle that I want to rotate it at, like so, and it flips over. I can also have picked the object, right click, go to properties, and under properties I can change the rotation angle under text, which is going to be right there. And I can change the rotation angle by picking 2 points from properties by selecting the geometric calculator, picking 2 points. It's a little button, angle of line defined by 2 points. Now I can come over, pick my 2 points. Once I pick the 2 points and I apply it, you'll notice whatever angle I selected gets applied to that dimension right there. So you got a couple ways you can fix this. You can do it while you're placing the dimension by typing A for angle and changing the angle of the dimension. You can do it after the fact by selecting properties. Do the same thing over here, by the way. Let's do that one with properties actually. If I pick that, right click, go to properties. Under properties, I say I want the text rotation angle, bring up quick calc, to be at this angle right here. Apply, it rotates the dimension. Now I can grab it, pull it up above the line, and now it's in the right orientation. Now let's go ahead and place the hatch pattern in here. The hatch pattern is going to be annotative as well. I'll double click in this viewport and I'll move on in. If I go to the hatch command, there's a couple of things. One is I want this to be annotative, but picking annotative alone isn't going to give me a hatch that looks good. Here's why. If I go ahead and just place that and say, yeah, make it annotative, then I go and do a preview, you'll notice that it's filled right in because the scale of that hatch pattern is set to 1. That means the spacing is 1/8 of an inch, and 1/8 of an inch on the ground is a very, very, very tight hatch pattern. So what I want to do is scale that hatch so that it's relative to the paper space layout that I'm in. So I go back into my hatch pattern. I didn't mean to accept that hatch pattern. You can see that it's a lot of entities, so let me just erase it. So I go back into my hatch pattern. This time, instead of just picking this annotative, I also pick relative to paper space. Select my points. I have the option of separating them as separate hatches too, which probably in that case I'd want to do. So let's just do that. I do a preview now and it comes in the right scale. Everything looks pretty good. I go over and look on this side though, I don't see a hatch over here. If I want to see the hatch over here, because it's an annotative hatch, I have to assign the same scale to this that I have in the viewport. Only one annotative scale has been assigned right now, and that's the one in this viewport. So I'm going to go over here, make that viewport active, select the button called Annotative Visibility. That shows all of my annotative objects everywhere. That allows me to select both of those hatch patterns, right click, go to Annotative Object Scale, and just say Add Current Scale. Now it looks correct here, it looks correct there. I get a few things I don't want to see up here, a few dimensions, so I just go back and turn those off again. Now I have the viewport showing the hatch scale at the right scale here, hatch pattern at the right scale, and I have the same thing over here. Now let's just say I want to put a little piece of text down here. Maybe I want to identify that as a house. If I look at my styles, I have one annotative text style. I'm going to set it current. I come back out. I use the dtext command, and I say let's put some text right here. Let's make the height of that text 0.25. Well, make it 1.12. The angle is going to be east, and I just say this is a house. I put it in like so. Alright, nice and small. Doesn't show up over here. If I say, I'd really like to see that over here, what I have to do is go and make that the active viewport, turn on all my annotative objects, pick the one I want to add the scale to, add current scale. Now it's scaled properly for that viewport. Then I can turn everything else back off. Now you notice, however, it's at a slightly different angle. Not only is it a slightly different angle, but it's also in a different, in a position that I might want to change. If I grab it right now and move it down, it moves independently of the other annotative scaled version. I can do the same thing over here. I could put the word house over here. It doesn't change this one. That's one of the nicest things about annotative objects. If you grip edit them and move them around, you can have different annotative scales in different locations. What you can't do, however, unfortunately, and I'm surprised about this a little bit, since you can grip edit to move, I'd like to think that you could grip edit, right click, go to rotate, and then rotate one independent of the other. And if I did that so I could try to straighten that out, you notice that both of them rotate. So if I came over here, then the rotation of that one would be incorrect. So if you really want them at two different rotation angles, you actually have to put in two different pieces of text. Now make sure you put a detail title over here, house detail. Make sure you put the proper scale. And when you do this, don't do it on B size, do it on C size, and don't use either of the scales that I've used here. I want to make sure that you understand this. And just as a reminder, viewport scale and plot scale are only the same thing in AutoCAD if the units you use in plotting, inches, are the same as the units you used in drawing. We didn't use the same units here, we used feet. The scale is always paper space to model space units. So a viewport scale of 1 to 100 would actually be a plot scale, in this case, of 1 paper space unit to 100 model space units, 1 inch to 100 feet, 1 inch equals 100 feet. And the other thing is, and this is one drawing where people in the past sometimes have felt that the only thing they needed to do was get this thing done. And that is not the point of this. I can do this drawing, of course, and so can all the other instructors here and all the other students. The idea here is to understand all these concepts. So your job is to understand them, and if you don't, to go back and do it often enough so that you can, do it over enough so you do understand it, ask questions in class. But this drawing by itself, when you get done, if you understand everything you've done here, you have a very good handle on paper space. When you're done, do a preview, make sure it looks good. You notice you got the house here, the layout, all this stuff looks pretty nice. Then you go ahead and answer your questions.